Okay, hi guys. So today our next task, and let's take a look at this task. Okay, so the next task is find subsequence of length k with the largest sum. So we are given array nums and some integer k, and you want to find subsequence of nums of length k that has the largest sum, and return any such subsequence as an integer array of length k. A subsequence is an array that can be divided from another array by deleting some or non-elements. So is array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. So, for example, we have some array 2, 1, 3, 3 and k2. So we need to find the subsequence of two, the most largest elements, and we see that actually it's this 2, 3 because the sum is 6. We have another example, minus 1, minus 2, 3, and 4. We have to find 3. So we can, for example, delete minus 2, and we can get this subsequence. Okay, so question quite understandable. So let's think about constraints. So actually, we don't care about duplicates. We don't care about values like maximum and minimum. If they're integer, it's okay for us. We are not adding or doing some calculations, so we don't care about them as well. And the length of our array could be big one. So if it's big one, so for example 10 in fifth power, then sorting probably, yeah, so we can use actually sorting here. But at least we need to find k most, like k greatest element. And to find the k greatest element, what we can do. So let's straight away go to solutions. So the first solution is straightforward. So we can sort our array. So for example, if we have array -1, -2, 3, and 4, it's all like we can it's already sorted, and we can go like when we sort this array, we can go from the right and take until minus element. So when we face minus element, we stop and go from the left until k not equal to null, to 0. And in this case, time complexity would be the complexity of sorting, and space complexity would be constant. Okay. The second approach, let's think what we can do. We can also use priority queue. So we can put all these elements into the priority queue and then take the k elements. So pq in this case would be also time of n log n, and space complexity would be of 1 if we are not consider result array. Can we do it more efficient? So, for example, yeah, so k, what can be k? K, it's also can be num length. So actually, I don't see how can we improve it. So actually, all of these two approaches is kind of the same, I think. I think priority queue even can be worse, because for each element we need to do some this searching approaches, and with sorting it can be probably done more faster. But let's, as we have like task priority queue, let's do it with priority queue then. So what we have priority queue, of integer, new priority queue. Okay, then what we do, we actually just go by our nums and PQ and our num. Then, while k is greater than 0, we have our result array with k, and in this while loop, we just put into our result array, k minus 1, we just put pq get or poll, let's say, our element, and we return our result. So I think it's quite straightforward. Let's just run it. Okay, and here int cannot invoke int value because the return value is priority queue poll is null. Okay, so what do we have? Yeah, so we also need to do like something like this. Okay, so here we see that output is to 1. Yeah, because we are probably making into our PQ elements less. So let's do something like this. So now it's greater, and let's submit it. Okay, we have wrong values, output, and expected 5075. Okay, so actually there also should be sorted, as I understand. So k minus 1 and how can we get, like, for example, we have k elements and what would be if okay, yeah, let's have some I. It will be easier, I think. Okay, so let's say I is less than k minus 1. Okay. Mm. 4, 3, 1. 4, 3 minus 1. Yeah, so what I have is actually the following. So I see here the same result. So I need also to sort them. Because here, first greater and then less. And here less and then greater. So I'm not sure that I understand. What's the point? Minus 1, 3, and 4, but my output is 4, 3, and minus 1, but it's still correct. 4, 4, 3, like -1, 3, and 4. Okay, let's do the following. So let's do the following. So for example, what we do, we can if they need subsequence and it should be in some specific order, and it has also duplicates, so we can like put in our priority queue, right? Then after we put into our priority queue the greatest values, we can take from our priority queue k elements, right? And so while k is greater than 0, and we can get like pq pole, it would be our greatest element. And we can have like a map of integer and integer, map new hash map, and then we can do like map like we are taking some value from pq, then we get like map put value, and here like map get or default map value or 0 plus 1. So we are doing something like this, and then we can go through our array like integer I equal to 0, I is less than nums length, I plus plus, and then we are taking int value from nums I, and after we take this value we can get like if our map get value is not equal to null, so we can have this in our map. What we do, so if our not equal to null and map get value is greater than 0, then we can add into our result array. Let's have also j as would be our counter. So into result j plus plus, we can get like map value. We can put this value, and also we can put under the value, we can get like map get value -1. And in this case, we can do something like this, and let's run it. So let's check. Okay, priority queue is null. So here we also need to decrement this k. Okay, and let's submit it. Okay, so we are done, and let's check some solutions. So yeah, we have vector, we have counting, the same with map probably. So yeah, I think we are done for today. Thank you very much.